Welcome to Get Your FRQ On. This is question 5 from the 2007 Calculus AB exam. In the question stem, we're given some information about a hot air balloon whose volume is increasing, and we have a table of values which gives us some values for r prime of t, telling us how fast the radius of this hot air balloon is changing over time for a handful of different values of t. In part A, we are asked to estimate the value of r when t is equal to 5.4 using the tangent line, and then to determine if this estimation is an overestimate or an underestimate. And we have a few different things to do before we can successfully answer this part of the question. We do need to come up with an equation for the tangent line. Not too difficult. We are given that r of 5 is equal to 30 and that r prime of 5 is equal to 2. So if we write the equation for the tangent line in slope-intercept form, or write it in point-slope form and then just change it into whichever form you're comfortable with. Unless specified, it doesn't really matter which form you write it in as long as it's correct. The equation for the tangent line to r of t when t is equal to 5 is given by y equals 2 times t minus 5 plus 30. So now that we have our tangent line, we have to use this tangent line to approximate the value of r when t is equal to 5.4. All right, so r of 5.4 should equal 2.0 times 5.4 minus 5 plus 30. And if we do the calculations for that, we should get r of 5.4 is 30.8. Next, we have to address the fact whether or not this is an overestimate or an underestimate. And because we are given that the graph of r is concave down for all values of t between 0 and 12, this approximation r of 5.4 would be an overestimate of the actual value of r of 5.4. In part B, we are asked to find dv dt when t is equal to 5 and give it with units. All right, using implicit differentiation, we take the equation for the volume of a sphere, we implicitly differentiate, and we get dv dt is equal to 4 pi r squared times dr dt. Well, if I want dv dt when t is equal to 5, I need to know the radius when t is equal to 5, and I need to know the rate at which the radius is either increasing or decreasing when t is equal to 5. And in the question stem, we have both of those pieces of information. Dv dt at t equals 5 is going to be 4 pi times 30 squared times 2.0, which if we simplify is 7,200 pi. Just a reminder, when it comes to the AP exam and free response questions, you generally do not have to simplify numerical answers once it's only arithmetic that is left to do. If there's still some algebra that has to be done, yeah, you still have to do that. But even an answer of 4 pi times 30 squared times 2.0, if correct, would be accepted at least for the answer point if you are eligible for it. All right, so the volume of the balloon is increasing at a rate of 7,200 pi cubic feet per minute. The radius is given in feet and volume is measured in terms of cubic units. So the volume of the balloon is increasing at a rate of 7,200 pi cubic feet per minute with the correct label. Part C, we are asked to estimate the integral from 0 to 12 of r prime of t dt with 5 rectangles, provide the units, and give an explanation of what this integral means. The question requires that we use right-Riemann sum rectangles based on the given table to approximate that value. Okay, so the integral from 0 to 12 of r prime of t dt should equal, and then we need an expression here that gives both the function value that we're using to get the height of the rectangle and the width of each rectangle. And in most cases, if not all cases, when a question like this shows up on a free response question, you must show the expression that shows the product of each width times the height of each rectangle. So you must have the expression that is basically the sum of areas of rectangles. You generally should not skip over that. There are some ways to do this which earn all the points in one expression. There are other ways to do this over a couple of different expressions where you simplify over the course of a few steps. But you must show that product, that sum of the individual products, typically in order to get most or all of the points for a question like this. All right, so based on the table, the different widths are 3, 2, 4, and 1, and the function values that we need are 2, 1.2, 0.6, and 0.5. Sorry, forgot the 2 and the 4.0. And so we write that, we do the computation. It's not a calculator question, so you will have to do this one by hand if it shows up something like this. When we do the computation, we get 19.3 feet. But again, as long as there's no algebra left to do and it's just arithmetic, you can typically leave it unsimplified. All right, so the units would be feet, and then the meaning, right? So the integral from 0 to 12 of r prime of t dt would represent the net change in the radius of the balloon in feet from t equals 0 to t equals 12. In part D, we are asked if the integral from 0 to 12 of r prime of t dt from the previous part of this question is more or less than the actual value of that definite integral, and to provide a justification for our conclusion. All right, in the question stem, we are given that for t between 0 and 12, the graph of r is concave down. All right, this implies that the graph of r prime of t is decreasing. Right, for all values of t between 0 and 12. Well, if the graph of r prime of t is decreasing for all values of t between 0 and 12, then the right-hand endpoint of each of the intervals in the table is the minimum value of the function on that particular interval. All right, if our estimate for the integral from 0 to 12 of r prime of t dt was based on all the minimum values in the interval, then our estimate is as small as possible. So the actual value of that definite integral should be more than our estimate. So from the perspective of our estimate should be less than the actual definite integral. All right, so our estimate would be an underestimate.